Okay, so yesterday we started talking about the parallel lines. So let me just say that I have two parallel lines and a transversal. And then we talk about the measurement of angles, right? I said, if I give you one angle, the measurements that I use were these. I said, if I give you one angle, you can figure out all the other angles. And then we talk about names like alternate interior, alternate exterior. Now for today, we're gonna talk about corresponding. So I'm gonna talk about the name corresponding and then the vertical angle theorem as well. Okay, now for corresponding, my angles are gonna be from the same side of the transversal. So they're both gonna be from the left side or both of them are gonna be from the right side. And they're different intersections as well. So I'm gonna use the word corresponding. Let me just do this with green. Corresponding. So different intersections. They're both from the left side or the right side. So from the same side of the transversal, but one of them is in between the parallel lines and the other one is outside of the parallel lines. For example, this angle with this angle. Notice how they're both on the left side of the transversal. So in this case, the left side. One of them is in between the parallel lines and the other one is not. Different intersections, right? That's an example of corresponding. Interesting part of corresponding, my angles are going to be equal to each other. The other one, the other angle we're going to be looking at is vertical angle. Now, vertical angles, we talked about this already. When there's an X formed, opposite angles. So they have to be from the same intersection. An example could be this 100 with this 100. When there's an X form, opposite angles are equal. So that's basically what we're going to be looking at. So here, number 25, this is what we call corresponding. I know corresponding angles are equal to each other. So I'm just going to go 130. It's equal to 17x minus 6. Got to solve for x. So separate into the equal sign. My minus 6, let me move it over as a plus 6. So I have 136 is equal to 17x. Let me divide by 17. So I got that 8 is equal to x. 136 divided by 17 is 8. Not bad. Let's take a look at question number 26. This is another example of corresponding. I know corresponding angles are equal to each other. So 12x plus 6 is equal to 11x plus 13. Okay, gotta combine like terms. So I'm gonna move a few things. My 11x, let me move it over as a minus 11x. My plus 6, let me move it over as a minus 6. Letters on one side, and then just numbers on the other side. 12 minus 11 is 1, so 1x equals 13 minus 6, 7. X equals 7. If I have another number in front of x, divide both sides by that number. Not that bad. Let's take a look at number 27. Let me flip the page. 27. Now that looks like a vertical angle theorem. I see an X form. And then these two are opposite from each other. So they must be equal to each other. So I'm just going to go 15x. It's equal to 14x plus 5. Let me separate them to the equal side. When I combine like terms, so this 14x, let me move it over as a minus 14x. I know 15 minus 14 is 1. So I have 1x is equal to 5. Okay, so I'm done on that one. Now here, 28, this is an example of vertical angle theorem. That little red box, that means 90. And I'm talking about these two angles. I see there's an x form, so they're equal to each other. So 16x minus 6, it's equal to 90. Okay, I'm gonna combine like terms. So this minus 6, let me move it over as a plus 6. So I get 16x is equal to 96. Notice letters on one side and numbers only on the other side. Let me divide both sides by 16. X equals 6. Not bad. Take a look at number 29. So there's extra stuff in here. Let me emphasize my two parallel lines that I'm using are this two, and then the line right here. My transversal is going to be that one. So it seems like I'm looking at these two angles. Okay. They're on the same side of the transversal. One of them is interior, one of them is exterior. So that's what we call corresponding, right? And I remember I said corresponding, they're equal to each other. So let me go 26x minus 2 is equal to 24x plus 2. Okay, I want to combine like terms. So let me move my x's together. So this 24, let me move it over as a minus 24. This minus 2, let me move it over as a plus 2. Letters on one side and numbers only on the other side. I know 26 minus 24 is 2. So I had that 2x is equal to 4, right? Because 2 plus 2. Let me divide by the number in front of x. X is equal to 2. Not bad. Let's take a look at number 30. Let me emphasize that my two parallel lines, I'm going to be using, let's see, I use this line. I don't use the other two, so it doesn't matter which one I pick. I'm going to use this one. And my transversal is going to be this one. So I'm looking at these two angles. All right, it seems like I form an X. They're opposite from each other, so that's vertical angle theorem. Let them equal each other. So 38x equals 37x plus 2. I want the x's together, so this 37x, let me move it over. Don't forget to switch the sign. I know 38 minus 37 is 1, so 1x is equal to positive 2. That's it.